Okay, let's record. Sorry to say that I'm not good in heat and dissipation, Anna, but I think it's not that difficult because it is a very straightforward punya question ya. Dia tak sama dengan tadi kita apa yang kita belajar dengan magnetic circuit. From there, one step, then another step, then become another step. No, it's not. It is more to partially theory, 50% theory, and 50% calculation. So, okay, just now we talked about the conduction, whereby the heat is passing through by medium. Medium like the wood, glass, steel, anything lah, from one end to the other end. Radiation too is a ray, like X-ray, gamma ray, atomic bomb. The heat is when it like the Nagasaki, right? When the atomic bomb bombed Hiroshima and Nagasaki, and then the heat is spread all over the land sides. That's a radiation. Another one is a convection. The heat dissipated by convection is classified into two categories. One is the natural convection, another is artificial. Artificial means buatan. Buatan orang lain. Okay, what about natural convection? Convection is a liquid and gas particle near heated body becomes lighter and rise, giving place to cooler particles which in turn get heated and rise. So for example, the oil, we have a tank of oil, okay, a tank of oil, right? So when we heat up, okay, when we heat up, so the heat, then it will go, the hot one will go to the top, and then cool one will go to the bottom. Then this is called natural convection. Artificial convection, heat is removed by artificial circulation of a cooling medium, which means we give something, push it. For example, motor, pump. A transformer tank may be cooled by a blast air on it. Turbo alternator cooled by the circulating hydrogen. The usual method for the cooling machine by blasting air on a heated surface. Oh, sorry, not pump. Sorry. It's like we put a fan here, then we blow it. Okay, this is how we call artificial convection. So there's a formula as well. Formula you need to memorize. I'm not sure whether the formula will be given in the exam or not. But please remind me to ask me when the exam is near to the time. And then heat flow in a watt, heat transfer coefficient, watt meter squared, degrees, area, surface temperature, and a fluid temperature. Cooling of electrical motors, and I think in the end we have the examples, the calculation examples. Cooling of electrical motors and transformers. Just now is only the three we call three methods of the so-called what general method on heat reducing the heat or cooling the machine. So now we go into the application of the electrical motor and transformer. So for electrical motors, in most cases, heat dissipation is achieved through the conductive cooling through medium. In this method, heat is transferred from the motor through the mounting interface into the surface structure, heat sink. So for example, the heat is released by the strip here, the sink. Okay. Another method to remove heat from the electric motor is providing forced air. This is forced air. They have a fan, commonly done by providing an electrical fan to blow air over the motor. Liquid cooling can also be used to dissipate heat from the electrical motor, for example, by using this water cooling. With the liquid cooling, ethylene glycol or liquid cooling agent is circulated in or around the motor housing or coils to dissipate the heat. So, for example, for example, there's a water go inside the stator, and then another way is go out, flow out. So this is the so-called liquid cooling. It's like our car engine. Our car engine also the same. The water circulated the combustion area. Okay. So the code, we have IC 01, 40, 41, 43, 43R, 61. Usually we will look at, we will have this code uh, at the nameplate of the electrical motor. There's a lot of enclosure. Just have a look, will do. Cooling transformer, okay. No transformer is truly an ideal transformer, and hence uh, this means that the transformer will have losses. It is no ideal one. Ideal means there's no losses. And hence it will incur some losses, and most of which get converted into heat. So the transformer, for example, our charger, when we open up, when we switch on our charger and then charge our handphone, the charger itself is actually a transformer. Inside got transformer. Our laptop adapter, that one also transformer. When we open up, switch on quite some time, then it become very hot. How it reduce? It use convection. The heat released through the air. If this heat is not dissipated properly, the excess temperature in transformer may cause serious problem like insulation failure. So transformer inside got a lot of coils, and then the wire coil that easily to be melt if let's say more than certain temperature. So it is obvious that transformer needs a cooling system. So transformer can be divided. This one for transformer cooling system, careful, will come out. We will focus on this one in this topic for the test one. So we have two types: dry type, oil immersed type. Dry type and oil immersed type. So different cooling methods are: we have a dry type transformer and oil immersed transformer, and there's a several short form. For example, air natural (AN), air blast, oil natural, air natural, which means inside the transformer they use oil, and then the transformer oil heat released by air natural. Just use a sink. Later we'll see the picture. We have an oil natural, we have an air force, oil force, air force, oil force, and water force. We'll see how. For dry type transformer, dry type, which means the transformer itself, okay, the transformer itself, that's the when it close into the casing, okay, it is nothing here, nothing. Okay, so dry type transformer never uses any insulating liquid where its winding with core may be immersed. Rather, windings with the core are kept within a sealed tank that is pressurized with air. So this everything here is air, air. As the size and the capacity of transformer increase, the associated cooling arrangement become more powerful and sophisticated. So by definition, the transformer cooling system is such arrangement for power transformer which limit the generated heat into a safe value by means of proper dissipation of a generated heat. Okay, just put an example. Dry transformer is like our handphone charger. There's no oil inside. There's no oil inside the plastic. Okay, so dry type transformers are available in a few general classes of insulation. The main feature of insulation are to provide the dielectric strength to be able to withstand a certain thermal limit, and they have a classes. This is the classes. If I say the transformer can sustain below 105, it's class A. If the transformer can sustain more than 220, it is class R. So what about air natural? The cooling method is used in the dry type transformer with a smaller rating. We use air natural. As the name implies, the natural circulation of atmospheric air is used in this technique. So very easily, air natural means they use air just to release the heat. When the transformer is operated in a full load, the temperature of the transformer becomes greater than the ambient air temperature. Ambient temperature means the environment. If let's say for example, right now we are in the room temperature. That one is called ambient temperature. So if let's say it's greater than the ambient air temperature, so by convection process, the light and the heated air gets replaced by the heavier and comparative cool surrounding air. So for air natural, To cool down the dry type transformer, we use a convection type. Also uh, the so-called the air with a heated one, it become very volatile. So it can flow random. It can use how to say random movement, and then it also become the light and heated air. So it become more lighter. So it will move around. And then, but this type of cooling arrangement provides satisfactory operation for low voltage transformer. For example, our charger lah. Air blast. Air blast means we cool with a high velocity in provided in the core lah. For example, we use a pump to blast the air inside the transformer or air blast. Then this additional air force ensure quicker heat dissipated of the transformer. The fan are automatically controlled. That is when the temperature of the transformer core goes beyond the safe limit, then all the fans are switched on. Air force cooling method provides better performance than natural air cooling, but additional cost is associated for sure because we need to install the fan, right? So this is different. Air natural is nothing, just air. Air blast, we need to blast it. We need to make sure we have turned on the fan, tube conditioner transformer. So advantages: maintenance and pollution-free solution, site clearance, excellent capacity to support overload, reduce cost, long-lasting, suit for damp and contaminated area, easy, environmental friendly. So this is the dry type transformer. Disadvantages: dry type transformer is long-lasting with a less chance of a winding failure. But once it fails, whole setup is to change. Completely change of the high voltage and low voltage winding with the limbs. For some power and a voltage rating, dry type transformer is costlier than the oil cold transformer. Well, for the advantages, we can see that it's more. But disadvantages here because one is a breakdown. Breakdown means damage lah. Then everything will gone. Dry type transformer are widely used in where? Chemical, oil, gas, environmental sensitive area, fire risk, inner city substation, indoor and underground substation, renewable generation, offshore wind turbines. Then this one is oil immerse. Oil immerse means kita rendamkan dia punya transfer ke dalam oil. This is the most commonly used lah in Malaysia. Liquid filled transformer, liquid filled transformer. Transformer yang memenuhi dengan liquid. Have a coil immersed. The coil is immersed in an insulating medium. This insulating medium is a liquid. Then usually it's oil, or we call mineral oil. Serve as a both insulator and provide a good medium to remove the excess heat. So it also as a medium to release the heat. So the main source of the heat generation of transformer is copper loss. Usually in transformer is copper loss, I2R. For the core loss and hysteresis loss will be smaller because the frequency is not that high. It's about 50 Hertz. So although there are other factors contribute, heat in transformers such as hysteresis or eddy current loss, but contribution of I2R loss dominate them. For transformer, yes, I2R is more than the hysteresis and the eddy current. Because eddy current and hysteresis is very dependent on the frequency of the supply. Our frequency supply only 50 Hertz, so it's very small. And the temperature of transformer will rise continually, which may cause damage in the paper insulation and the liquid insulation. The nameplate for 4 letters represent the cooling method of the transformer. So usually how we know that the cooling system of the transformer, we see the cooling classes lah. First character is the medium. Mechanism, how. Medium is what. Mechanism is how. And then this is for internal, this is for external. So later we'll see how. This is the several items. So for example, O is for mineral oil, K is a liquid, L is a insulating liquid, no measurable fire point. Second letter natural, force, and then D is for direct for the cooling equipment, air, water, natural, and force. Something like this. Later we'll see how is it. Other example. Maybe we go for this example first. So got from this we call the structure of the transformer. We can see this is the core, then this is a winding, and then it immersed into the medium, and then the medium tank we have a radiator, radiator. So what is the type here? ON, oil natural. So this is oil, this is natural, internal one. So inside here, this is oil, and then how it release the heat? The mechanism is just flow normally, just flow normally, naturally. So that's why the mechanism is natural. And then external one is air natural. So when the heat goes through here, so how is release the heat to the outside? Just by using air. And then the mechanism is naturally. Naturally. So that's why in the transformer like this, we just put ON, AN, okay, or OI or OA. But usually we use this one, ONAN. So this is how we use it. Maybe yeah. So, okay, I think just now already discussed, just to let you know that this is how we define the ONAN and how we apply this one, this and this. Then this one is ONAF. ONAF. So have a look on internal first. Use oil and natural. So oil and natural. Better. Okay. But outside it use air and it is force. This is no force. No force. So but force. Force means we need to have a fan. So force airflow. Okay. Then another one. OFAF. OFAF. So oil force. This is oil. Okay, we have oil. And then force means we need to have an oil pump so that it can flow faster. Another one is air force. So this is released by air, but need a force. Air force. Okay. And then we have a OFWF. So oil force and then water force. So inside the tank is oil. Force means we have a oil pump. So settle. Then outside, okay, this will flow into another medium. We use water go in and water out. So it's a water force. Okay, okay, this is the example. So now, okay, one thing I want to tell you, please go back and do this. I think I need to assign some work for you, because since first slide, ramai yang tak buat kerja tu. So I think maybe I need to assign some of you, and then in the next class, not the coming replacement. Next class, I will just pick a name to do. So go back to have a try. Example 1, 2, and 3. Salah tak apa, salah tak apa. Just have a try. Then I will let you share your screen to explain. Okay? So this is the chapter number 2. Okay or not? I think I need to stop recording.